So today we're going to look at parabolas. There are 4 basic conic shapes that come from that double nap cone that I just showed you. Circle, ellipse, parabola, and hyperbolas. So we are going to study the parabola today. Very exciting. It's the easiest one, I think. And the parabola is the set of all points that are equal distance from what's called the focus and the directrix. So this particular parabola below here, we're just going to assume that the vertex is at the origin. So if I had a vertex at the origin, let's just say for chuckle's sake that my parabola opened up, because it could open down, it could open right, it could open left. Then the focus is going to be inside the parabola. That's my focus. This was my vertex down here. So the focus is always being protected or surrounded by that parabola. It's always on the what I would consider the inside of the parabola. Whereas the directrix, you're going to use the straight edge. Difficult for me to do so. So this is your directrix. It is a horizontal, or it could be a vertical line, depending upon if the parabola opened right or left. Is a horizontal line that is equal distance from the vertex to the directrix as the distance was from the vertex to the focus. So the distance from here to here and the distance from here to here are the same. So the focus and the directrix are equal distance from the vertex. One is on one side, one is on the other side. And if I were you, and this distance is called P, really hard for me to put this in here, but the distance from here to here is P, and the distance from here to here is P. So those are the 3 important things: your vertex, your focus, P, and your directrix. And then the last thing that you're going to be responsible for knowing is the axis of symmetry, which is always perpendicular to the directrix. So let's fill out a few things here. If I have a parabola that opens, let's see, it's y equals x squared, does that parabola open up, down, right, or left? Well, okay. In general, let's say that we don't know what the coefficient is in front of the x squared. So y equals x squared, is that an up, down, or a right, left parabola? Up, down. So this could be up or down. So our directrix for this one, and that's kind of why I drew this one first. Our directrix is going through what axis? For our up parabola, the y-axis. So our directrix is going to end up being y equals negative p. I'm not going to worry about the fact that it's negative p, because I'm going to show you a way to not have to deal with it. So you can memorize that. You can memorize that if you want to. I just choose not to. And then your focus is going to be at the ordered pair, if it's at the origin, 0, comma p. To the right 0 and up p units. Your focal width, no matter whether your parabola opens up, down, right, or left, is always the absolute value of 4 times p. And then I want you to add one more thing here, your focal length. Your focal length is p. That's the distance from the vertex to the focus, focal length. And you can add that in there if you want to. you can determine whether your parabola opens up or down if your 4p, so let's just bring this over here, if your 4p so if your 4p is greater than 0, it's going to open up or to the right. If your 4p is less than 0, meaning negative, it's going to open down or to the left. Those are your two negative directions. So then, what are the formulas for if we have x is equal to y squared? That gives you a parabola that opens right or left. One of the two. And again, it depends on whether 4p is positive or negative. If 4p is positive, it's going to open right. If 4p is negative, it's going to open left. And then your directrix is going to end up being, oh, what color do I want? How about purple? So your directrix, if you think about it, if you have a parabola that opens, let's say, right, won't your directrix go this direction? So your axis is going to go through the x-axis. So you're going to end up with it being x equals, for your directrix, negative p. Again, I don't memorize this, so don't get overwhelmed. It'll all make sense when we start doing a full problem. And then your focus is going to end up being p0. Your focal width is still the same, the absolute value of 4p, and your focal length is still p. So those haven't changed. Any issues, problems, or concerns before we look at when we don't have our vertex on the origin? Can I move the notes? Nobody's upset about that? Okay. So then let's look at the standard equation of a parabola. These I would memorize. Those you need to know. And so a couple things I want you to notice. The squared is always on the left side by itself. Everything else is on the right side. There is nothing in front of the squared parentheses other than a coefficient of 1. If there is a coefficient over here, you must divide it out so that it ends up over here. And so we'll have some that look like that today. Because the x is being squared, is this a parabola that opens up, down, or right, left? With the x being squared, we're going to have a parabola that opens up or down. So you need to know that. So up or down. Then so let's just, for chuckle's sake, go ahead and plot a parabola over here. So here's my vertex right here. And then I'm going to plot a parabola that opens down just for chuckle's sake. Then that means that my focus would be below the vertex here, and my directrix would be on the opposite side, but equal distance from the vertex here. So this is your directrix. And then your axis would go through and connect the focus and the vertex. So this is your axis. And I just pulled that out from whatever. So that's an example of an up-down parabola. So you're welcome to memorize the following items if you want to. I choose not to. Yes?
What if the red line's on the middle?
That's your axis. Axis of symmetry.
And then the focus, you just...
The focus is, and I'm going to show you how to find those. Don't worry about them yet, but you do need to know that your focus is always being surrounded by your parabola. Your parabola is around it and protecting it, if you will. And so your focus is always what I would consider the inside of the parabola. Your directrix is always on the outside. Your parabola is always opening away from your directrix and going towards and hugging your focus, if you want to think of it that way. And so you can memorize the following formulas or not. It's up to you, but I choose not to. But I'm going to give them to you anyway. So with an up-down parabola, your focus is an ordered pair, and it would be h, comma, k plus p. What I would know if I were you all is I would know off of these formulas that your vertex is always what? H comma k. So just like the equation of a circle, your vertex is hk, the opposite sign of what's inside those parentheses. So that you do need to know. And then your directrix would be the following formula. Your directrix would be y equals k minus p. Your axis would be x equals h. Your focal length will equal p. That's your distance from the vertex to the focus. And then your focal width is equal to the absolute value of 4p. So the other equation, this one here, has your y being squared. If your y is squared, then you have a parabola that opens either right or left. And again, that depends on what your 4p is. So for chuckle's sake, I'm going to put our vertex at the same place as the last one, give or take. But this time I'm going to have a parabola that opens to the right. That means that my focus is going to be to the left of my vertex or to the right. Left or right, focus. Right. So your focus would be somewhere here. And then my directrix would be equal distance, but this time it's a vertical line. So this is your directrix. And then your axis is perpendicular to that, connecting your vertex and your focus. So this is your axis. And that's just an example. Again, it's pulled everything out of a hat. And then your following formulas, if you care to memorize them, I don't, but here they are for you, are slightly changed. So your focus for the right-left would be h plus p, comma k. Your directrix is going through the x-axis this time, so it's x equals h minus p. Your axis is going through the y-axis this time, so it's y equals k. And then your focal length is still equal to p, and your focal width is still equal to the absolute value of 4p. Now, if you ever ask me that again, I'll tell you I have no idea what they are. I can figure them out, but I don't use the algebra. So as soon as you have that written down, we'll actually work some problems. I mean, if you wanted to memorize them, they do tend to make some sense, but The problem is once I add circles, ellipses, and hyperbolas to the melting pot, then the x's, the y's, the h, the k's, and the p's, they all just get melded and mixed up together. And you end up having to memorize a whole lot of stuff. And I would just prefer that you understood what it was that we're doing. Can I move it? You good? Okay, so let's look at example 1. We have to find the vertex, the focus, the directrix, the focal, oh, I totally missed that in the last class, focal width, and we're going to graph the parabola. So, let's just start with the fact that we need standard form. So step 1 is standard form. And this parabola is not in standard form. The equation. The first thing I need is my squared term on the left and everything else on the right. So I'm going to flip-flop the equation and write it as 2x squared is equal to y. Is there any other problem that you see right now? The 2, you cannot have anything in front of the squared term, so we have to remove the 2 by dividing it out. And so we end up with x squared is equal to, and instead of writing it divided by 2, we need to look at it as a coefficient. So what's the coefficient of y? So we have 1/2 y. That's still not quite good enough for teaching purposes. I want to find, I don't have any parentheses here. So I want to find out what is being added to and subtracted from my x and my y. So x minus something squared equals the 1/2 times y minus something. What is being added and subtracted to the x and the y? If you don't see it, what is it? No, 0. So it really is x minus 0 and y minus 0, isn't it? Isn't x minus 0 squared the same as x squared? And y minus 0 is the same as y. So the point to that is, I want to find my vertex. Yeah, so I'm having issues, sorry. My pen keeps turning on me. So step 2, vertex. So my vertex is 0, 0, because this is my h and this is my k. And so I'm going to plot that vertex of 0, 0 right there. And I'm going to label it as V. Now, does my parabola open up, down, right, or left? Well, let's put it this way. Is it an up or down, or right or left, first of all, with x being squared?
Up or down.
It's up or down. So we're going to just start off. Sorry about that. We're going to start off with up or down. And how do I know which that is?
Because it's x is in front of x is equal to.
Well, since my 4p, isn't this 1/2 right here?
Yeah.
This 1/2 right here is 4p, isn't it? Isn't that where my 4p should go? In front of the non-squared parentheses? This 1/2 is identical to what 4p is going to equal. Because if you go back and look above at your general equation, isn't 4p in front of y minus k? So the 1/2 represents 4p. And so 4p is positive. When 4p is positive, doesn't your parabola open up? So I know I have a parabola that opens up. So at this point, I am totally fine with you sketching a parabola that opens up. I don't care how skinny or how wide you make your parabola, that doesn't matter to me. I'm happy that you know it opens up. Math Excel is going to want you to find another point, probably, to plot. And so you're going to use the parabola graphing tool. And then you're going to have another point to plot so that it can graph the parabola. How are you going to do that? You already know the vertex 0, 0. That's your one point. What's your second point? Choose any value you want to for x. What's an easy value to choose and plug it into this original? 1. If x is 1, square it, what do you get? 1 times 2 is 2. So wouldn't you then plot the other point 1, 2? So technically I should have a pretty skinny parabola, right? I don't personally care about that for conic sections. All I care about is, can you find the vertex, can you find the focus, can you find the directrix, and the axis of symmetry. That's really the most that I'm concerned about. And those are all easy. You know, if you want to plug and chug points and make it accurate, that's your business. You go right ahead. Yes.
For the formula, why'd you put zeros with the x and y?
Because there was nothing here. There was nothing being added or subtracted to my x or my y. You'll see what that looks like as we go further along. Since I had no other terms, it has to be 0 and 0. Okay? All right, so there's that. Then I need to find my focus next. So to find my focus, I will also find my directrix at the same time. Because they both involve the use of P. I have to find P because the focus and the directrix are P units away from the vertex. In this case, they're P above and P below. So to find P, I'm going to take what 4P equals and set it equal to that and solve for P. So because 4P is equal to 1/2, that's the equation I set up. Whatever is in front of the non-squared parentheses, that's what's equal to 4P. How are we going to solve for P? Divide by 4. So on the left, I'm going to divide by 4, but on the right, I don't want to divide by 4. What's the same as dividing by 4? Multiplying by 1/4. So I end up with P equaling 1/8. Ooh, that's a toughie. Because 1/8 is just a smidgey, it's a real technical word, a smidgey above or below V, right? So I'm going to take, and I'm just going to plot just a smidge, just a little bit above and then a little bit below. So is my focus going to be above or below? Above. So let's plot the focus first. So the focus, really tough for me to plot on this one. Well, close enough for government work. There's your focus. Oftentimes it's too hard for you to put your ordered pairs below. So long as you identify them as such in your work, I'm okay with that. So I'm going to identify the focus and I'm going to name its ordered pair. So here's where I'm not memorizing equations. I'm going to name this ordered pair. So what's the x value of this ordered pair? How far to the right did I go? 0. And then how far up from the origin did I go? Just 1/8, because my vertex happens to be at the origin. So I went up 1/8. So my ordered pair for the focus is 0, 1/8. So there's one of the items that they were looking for. So I found my focus, found my vertex, now my directrix. So my directrix is exactly, now you need to use a straight edge. It's impossible for me to up here, but we're going to go 1/8 below. So I apologize for the crooked, oh, that's not too bad, line. And then that is going through which axis? The y-axis at what point? Negative 1/8. And so didn't we just find the equation to our directrix? Y equals negative 1/8. I assume since you put it underneath the title that said directrix, that there's your directrix. Otherwise, you have to differentiate it between the axis equation and the directrix equation. And so that brings us to our final item, which is our axis of symmetry. So step 4, the axis of symmetry always connects the focus and the vertex together, and it is always perpendicular to the directrix. So you might want to put here that it connects the vertex and the focus. So my axis happens to be the y-axis. It goes through what axis? The x-axis at what value? 0. You just found the equation to the axis of symmetry without using those equations on above. Now the only other thing that they asked was the focal width. So step 5, focal width. The focal width involves 4p, and it involves the absolute value of 4p. Absolute value of 4p. is equal to the absolute value. What did we say 4p was equal to? 1/2, which equals, in our case, 1/2. So the focal width is going to be 1/2. P is 1/8, that's your focal length. Focal width, 1/2. All right, so any questions on that? Did I use any formulas really other than the standard equation? No, so I don't memorize them. So let's go to page 2, well, the back of your page. So the next one should go a ton quicker. So example 2. Is it in proper standard form? No. Standard form means that I have the squared part on the left. So this is my squared part. That means that needs to be on the left all by itself, and this needs to go on the right. So I'm going to put the y minus 2 squared on the left equals, and then how do I move x plus 3? Subtract it. So that whole thing gets subtracted. So it moves the other side as a minus x plus 3. So is this a parabola that opens up, down, or right, left? The y is squared, so when the y is squared, it opens right, left. So I'm just gathering some information. And then what does this right here represent? This right here, 4p, right? That's 4p, isn't it 4p? And it is a -1, isn't it? So our 4p is going to be a -1. Then this is our h. Where is our h? The -2 or the +3? Where do I put the h? Is the h with the x or the y? This one's a really easy one to mess up your vertex on. This is actually your h right here, and this is your k, because they're backwards. We're not used to doing it backwards. So step 2, my vertex. My vertex is actually -3 because we want opposite signs, and +2. So be really careful with that one. And so plot that. And is this parabola going to open right or left? Because we have a -1, it is going to open left, because 4p is negative. So because 4p is negative, we're going to sketch a parabola open left. Again, I don't care how skinny or how wide you make it. If that bothers you, then go ahead and choose a value for x and find your y. So like I would probably choose -4 because I know it's going to open to the left, and I want to get a value that's somewhat close to that. What's next? After my vertex, what do I need to know? Focus and your directrix. So step 3 is your focus and your directrix. What do I need to find the focus and the directrix? 4p. So above, again, what does 4p equal? It equals the -1. So this time when I solve for p and I divide by 4, I'm going to go ahead and divide both sides by 4. And my p is equal to -1/4. It doesn't matter to me that my p is positive or negative. That has no bearing upon what I do. None whatsoever. All I care about is that I'm going to put my focus either to the right or the left of my vertex. Which is it going to be? Yep, I want my parabola to protect it and hug it. So it has to go to the left 1/4. Okay, well that's going to be a little difficult. It's a smidgy to the left. Technically, that's not on my parabola, just saying. And so that's my focus right there. So we always label V and F on your graph. And then we're going to find that ordered pair. So your focus, how far to the left did I go from the origin? I went -3 and then an additional quarter, so wouldn't that be -3 1/4? And I'm fine if you wrote it as a mixed number, -3 1/4. I know that shocks you. Math Excel may not be so fine with that, so you might have to write it as a improper fraction. And then how far up did we go? How far up? 2. So there's your focus. And then your directrix is to the right of your vertex, again, 1/4. So I'm going to struggle with putting stray marks on here. So I'll do my best. Oh, not bad. So there's my directrix. And it goes through what axis? The x-axis, right? So it goes through the x-axis. Let's figure out what that is. So x equals, I start off by going, oh, I went to the left -3, but then I went backwards. Whoops. If I want to make -3 smaller, am I going to add that 1/4 or am I going to subtract the 1/4 from a negative? I want to add a 1/4. Adding a 1/4 is what's going to make that -3 smaller. And so what does x equal? Yep, x is equal to -2 3/4, or make that an improper fraction, x is equal to -11/4. So either one's acceptable. And so label this -11/4. Am I missing anything? My axis of symmetry, so that's step 4. So my axis of symmetry is always perpendicular to the directrix and connects the focus and the vertex. So it's going right through here. What axis is that going through? The y-axis at what value? 2. So that's pretty easy to find, y equals 2. And then last, what do they want? Your focal width. So your focal width is the absolute value of 4p, which equals the absolute value of -1, because that's what 4p is. So what is the focal width? 1. Easier the second time around? Anybody care to, at this point, memorize all those formulas? It's just about graphing and counting. Sometimes the algebra becomes a little cumbersome, as it will in example 3. So can you tell me what's wrong with example 3? It's not in standard form. So we do have to do a little bit of work to get it into standard form, and that's the only pain in the butt on this particular problem. So standard form, once you get into standard form, everything falls into place from there. So I see that I have an x squared. So since I have an x squared, what kind of parabola is this? Up, down, or a right, left? It's going to be an up, down. So I want all the terms that have an x together on the left side because that's where my squared part goes. And everything else is going to go to the right. And I'm going to have to complete the square. We've done a lot of completing the square, so this should start to come naturally to you. We'll see. So I've got the x squared minus the 2x. I'm going to complete the square, so I'm going to want a plus blank equals. And then move everything to the left. You either add or subtract. Here I'm going to subtract an 8y and subtract a 9. But I also have to put a plus blank on the right side, mostly because I want everything over on the right. So whatever I add to the left side, I have to add exactly the same value to the right side. I am not going to add a positive to the left and a negative to the right, because those are the same, they're opposite sides of the equal sign. So whenever I add something to one side of the equal sign, I have to add an identical sign and amount to the opposite side to maintain equality. If I'm adding my blanks on the same side of the equal sign, then you would add a plus minus, but my blanks are not on the same side. So here we go. We're going to complete the square. So I need to take b right here and do what to it? Divide by 2 and square it. So I'm going to take my b, which is -2. I typically don't put the negative in there, but for some of you it freaks you out. But the problem is when I put the negative in there, then some of you get the wrong sign. Anytime we square anything, what's the sign? Positive. So what's -2 divided by 2 squared? +1. So I'm going to add a 1 to the right and to the left. Now I will warn you that this will not always work out nice and pretty. Oftentimes your vertex is the ugly point on the parabola, and then the rest of the points you can fix and make them look nice, but your vertex could be the ugly point. So that's all right. You're completing the square. It won't be too bad. So then from here, we've made a perfect square trinomial that factors into a squared binomial. So you want to take the square root of your bookends. Square root of x squared goes here, and square root of the 1 goes here. So wouldn't that be an x and a 1? And then how do I determine my middle sign?
What's the middle side?
Yep, so because our middle term has a sign that's negative, that's why we have a negative in our parentheses. And then equals -8y, -9 and a +1 is a -8. Then we have to go to work on the right side. So this side's all done. This side needs some help. Nowhere in the standard form does it say that we have two terms. We only have one set of parentheses with something in front. It does not matter that these two happen to have a -8 in common. You're not looking for the greatest common factor. You're looking for whatever the coefficient of y is. So if that makes that a fraction, oh well, it'll be a fraction. Don't let it bother you. So whatever the coefficient of y is, that's what you're dividing every term on this right side by, because that's the coefficient of y in this case. And so that's going to come out in front. So I get a -8 out in front of parentheses. And what's left? +y and a +1. And on the left, I still have an x minus 1 squared. So now I can actually see my h is with my x and my k is with my y. So now I can go ahead and start graphing and finding what I need. So what's my vertex? Yep, so our vertex is 1, -1, and our parabola opens, we said it opens up or down. Which is it? What's our 4p? Is our 4p positive or negative? Negative. So because it's negative, what's it going to do? It's going to be down. And I'm also going to write in here that this right here is my 4p. There's my 4p. That -8 is my 4p. So I'm going to plot my vertex at 1, -1. And then I'm going to just sketch an opening down parabola. I don't care how fat or skinny, unless you do. Then what do I find? Focus and directrix. What do I need to find my focus and directrix? How far is the focus? Generally, what do I need to know? I need to know P, right? But we know what 4P is. So 4P is exactly equal to what value? -8. So to solve for P, we're always dividing by 4 or multiplying by 1/4. And so in this case, P is equal to what? -2. So that means I'm going to go 2 above and 2 below to find my vertex or to find my focus and my directrix. So does my focus go above or below the vertex? it goes below. And how far? 2 units. It doesn't matter that P is negative. That has no bearing upon what we're doing. It would if you're using the algebra, but we're not. And so that's our focus. Name that ordered pair. 1, -3. So there's one of the items we're looking for. And then my directrix is 2 in the opposite direction, so that's 2 away from my directrix. And I'm going to create a horizontal line going through what axis? The y-axis at what value? 1. So there's my directrix, y equals 1. What's next? What's missing? The axis, right? Axis. So for axis of symmetry. So it is perpendicular to the directrix. It connects the vertex and the focus. So here it goes. What axis did that go through? X at what point? 1. So our axis of symmetry is x equals 1. What else do they want? Focal width. So our focal width is based upon 4p, but this time it's the absolute value of 4p, which is equal to the absolute value of -8, which is +8. That wasn't so bad. You got to work on your completing the square and putting your equation in standard form. That's the key. If you can't put it in standard form, you're not going to be able to graph it. Because graphing it by now should be easy. Correct? Do you know how many of you keep looking at that clock? Stop it. There's been 5 of you looking at the clock. I don't know about you. I'm not looking at you, but I look out this direction. Okay, so let's look at example 4. There's 2 parts to it. They're going to give you they have to give you the vertex and the focus, or the vertex and the directrix. They kind of have to. What does the vertex and the focus help us with? Because in the general equation, what do I need? To write a general equation of a parabola, what do I need? H and K, and what else? P. What is P? The distance from what to what? The vertex to the focus, or the vertex to the directrix. So if they give me the vertex and one of those two, don't I know P? So I'm not using algebra, I'm graphing it, and I'm counting. So they have given me my vertex, which is H and K, and then my focus is going to allow me to find P. So let's go ahead and plot the vertex, -1, +2. So there's my vertex, and then my focus, we'll plot that, is -1, 0. So this is very important, because I can tell right now whether my parabola opens up, down, right, or left. And what does it do? It opens down, because we want it to hug and support and protect that focus. So I know I have a parabola that opens down. So since it opens down, I'm going to use the following equation. And so I'm going to try to move everything to the right a little bit. So I've now identified the correct standard form that I'm going to use. So I'm going to use x minus h squared equals 4p times y minus k. So I already know my h and my k. All I have to do is find p. Can't we find p real quick right now?
Yeah.
Just have to find, let me see if I can get it better. Maybe I'll use the purple. No, yeah, well. What's the distance from here to here? 2. So that means that p is equal to 2. I don't care whether it's +2 or -2. We already know what that is. Because 4p, for the parabola to open down, 4p has to equal what? For the parabola to open down, what's the sign of 4p have to be? negative. So we already have the 4, so what does the p have to be in this case? It's going to have to be a negative 2. So let's put a negative in front of that 2, and that's how I determine that. I knew my parabola opened down, so for that to work in this formula here, my p has to be negative for that to open down. So we're ready to start plugging and chugging. So we end up with x minus our h, which is negative 1, equals 4 times our p, which we've determined is negative 2, times y minus our k, which is positive 2. And then we're just going to clean it up. Take care of your double signs right here. You don't want a minus minus, so take care of those. So we have, oh, I forgot to square it up there, sorry. X plus 1 squared equals 4 times negative 2 is negative 8 times y minus 2. So here is our, what did I just do? Here is our equation. Wasn't that the easiest of them all?
How'd you get a negative 2?
Because I need to determine whether 4p is positive or negative, because that, if 4p is positive, then p is positive. If 4p is negative, then p is going to be negative. So because my p here, or because my parabola opens down, I know that my p has to be negative. If it opened up, my p would be positive. So let's do the very last one. So plot your vertex. They've given you h and k. So let's plot negative 2, positive 1. And then my directrix is x equals 1. So I plot a 1 on the x-axis, and I want to cut that x-axis into 2 pieces, so it has to be a vertical line. Does my parabola open towards the directrix or away from it?
Away.
Away. So it has to be a left-facing parabola. So if my parabola is left-facing, aren't we using the following formula? Y minus k squared equals 4p times x minus h. And because my parabola is opening left, I know p has to be negative. So let's find p. How far is it from here to the directrix? Because that's p. 3. So p is equal to negative 3, isn't it? This distance from here to here is what p is. And it has to be negative because our parabola opens left. So now we have our h, our k, and our p, and we can just plug and chug. So I have y minus my k is 1 squared equals 4 times my p is negative 3 times x minus my h is negative 2. So take care of any double negatives. So right here. And we end up with y minus 1 squared. Negative 4 times, or 3 times, negative 3 times 4 is negative 12 times x plus 2. And there's our equation. Any questions? So you don't have to graph everything. We're using the graph purely to come up with the equation. So notice I didn't graph the axis. I didn't graph the directrix on the other one. I didn't graph the focus on this one, so you don't have to. No, yeah, so this is a plus 2. In fact, if you want to add that, we can. So P is negative.